So now I'm going to state an important theorem about the geometry of functions called Rolle's theorem. This is named after the French mathematician Michel Rolle. So suppose a function meets these three conditions. Condition number one is that f is continuous on the closed interval from a to b. 2, f is differentiable. The derivative exists everywhere on the open interval from a to b. And suppose f of a equals f of b. In other words, the function has the same height at a and b. So in the example I've drawn here, a nice smooth function, this satisfies all three conditions. Then there must exist some point c on the interval from a to b such that the derivative at c equals 0. So in other words, if a function satisfies all these conditions, it's continuous and differentiable on the interval, and it has the same height at both ends, then at least at one point in the middle, it must have a 0 derivative. And so this is an interesting theorem. And one thing I'll say about calculus theorems, a lot of people use calculus for a lot of different reasons. Now, a mathematician will think a theorem like this is the greatest thing since sliced bread. Someone who is, say, an engineer or a physicist might not care at all about Rolle's theorem. It all depends on what you're going to be using calculus for. But as we'll see, on the mathematical side, Rolle's theorem will give us some insight into the geometry of a function.